Level 1 diagram of my project. So right here we have the Raspberry Pi Model B. It has a 700 megahertz CPU, 512 megabytes of main RAM, a USB controller, and storage. What I'm using for storage is a 16 gigabyte micro SD card. The CPU I actually have overclocked to about 900 megahertz in order to allow for slightly better connection times. Granted, it will reduce the life of the unit and create extra heat as well as use more power. However, the extra speed in uploading and downloading larger files negates that cost. Over here we have a Wi-Fi module that is plugged into the USB port. The USB port and the Wi-Fi module gives it a chance to connect to the Wi-Fi router, which I'm using my Ellipsis Jetpack 29cc. So from the Wi-Fi router, as being used as a gateway, I'm allowed to connect to multiple devices. Up to 4 devices connect to it at the same time, as that's how I have it configured at the moment. In order for power, the Raspberry Pi requires 5 volts, 2 amps direct current. You can either use an AC power supply that rectifies the AC current, or as I have it set up here, it is also able to run off of a 6 AA battery pack using a universal battery elimination circuit, or basically a voltage regulator that will rectify it to the correct voltage. The current rectifier I am using is working off of a DC power supply. The DC power supply is a 13.8 volt 2 amp power supply that works directly with the device. I found that using 4 AA's did not provide enough power, as the Raspberry Pi would not boot, and even once it did boot, it certainly would not power the Wi-Fi module. So I definitely needed 6 AA's. As long as I don't exceed the 15 volt range, I can add a few more AA's in order to increase the battery life, as well as the voltage regulator will keep a constant 5 volts. As shown in this setup, you can see that I currently have an 802.11 ABGN Wi-Fi router plugged into the Raspberry Pi microcontroller, as well as a SD card with a mini SD that is 16 gigabytes. This right here is a universal battery eliminator. What this does is this is essentially a voltage regulator that takes the voltage from the DC power supply that is currently underneath the table and regulates it down to 5 volts, 2 amps for the Raspberry Pi to utilize. The universal battery elimination circuit isn't completely necessary, however when using a battery pack it works fine. I'm currently not using batteries for the setup, as all of the power is currently drained out of them and they are currently charging. I was able to get about 6 hours of runtime without the Wi-Fi module and about 4 hours of runtime out of these batteries right here, which are Energizer rechargeable batteries, 2500 milliamp hour. In order for me to have a gateway router, I'm using this. This is a Verizon wireless Jetpack. I'm not currently using any of the external network connections, as I only need it to operate off of the local area network. So essentially what I'll have is I'll have this connection going in through the router and then going to the device that connects through it. The database is going to be stored on the SD card right here. To interface with the Raspberry Pi, what I need to do is I need to use an SSH command. So what I'll do is I'll do secure shell host into the IP address of the Pi. And then it requires me to type in my credentials. So now I'm actually logged into the Raspberry Pi, and if I use an ls, which is list command, then I can actually see all of the files that are located on here. So now what I'm going to do is I'm going to run an ifconfig. This basically ensures that all the network connections are working properly. So as you can see, all of the different hardware configurations are correct. It's running on the IP address. In order to demonstrate the functionality of this project, first I have the Raspberry Pi plugged into a power source, the wireless router plugged into a power source as well, and it's also using an antenna to boost the signal strength. And up here I already have it opened. I'm able to access the database simply by typing in the IP address of the Raspberry Pi. As shown here, I am currently using a Wi-Fi connection with my Ellipsis Jetpack. The other computer I will be using is my desktop computer, which is also connected using the wireless Ellipsis jetpack as well. This is also already preloaded with the website that is currently loaded. So in order to demonstrate, what I'm going to do is I'm going to put a file into the database, upload it, and then open it on the other computer. Okay, so as you can see there, it's uploaded and it's shown on here. So now I'm going to go over to my desktop computer, go into my Documents folder, open the file, and it is easily openable in rich text format. Currently stands, the project works as designed. However, there is still quite a bit of future potential for it. One of them is port forwarding. My current Ellipsis Jetpack gateway does not work for external network communications with the Raspberry Pis. It does not allow for port forwarding. If I were to use a separate router, or perhaps just make it a stationary device with a more advanced router, then I would certainly be able to start doing some port forwarding, so that that way I can connect to it from outside of the network. So I could use my phone essentially to connect to it if I just had it at my house as a base station. With the current security in place, such as the secure shell login and the certificate I created for it, I have no doubts that it would be a very secure system. It would also be very good if I could possibly implement an external hard disk for the device. That way, I could get hundreds of gigabytes, if not terabytes, of additional storage. I'd also like to see if I could potentially use a RAID array in order to significantly increase the speed of the server. However, that would mean that it would almost certainly be a stationary device that would be plugged into an AC power supply at all times, as I highly doubt that a battery system would be able to power an external hard drive. I learned quite a bit from this project about using the Raspberry Pi microcontroller and how to interface different devices together. I was able to successfully create a portable Raspberry Pi powered cloud server on a local area network that works seamlessly between operating systems such as Mac, Windows, and even iOS devices. However, I still like to try it using Android. The battery system still needs a little bit of work, as the batteries do not last as long as my calculations had initially provided. However, there is certainly more places that this project could grow, and I'm certainly going to be using this in my house as a cloud-based server that I can use for my own personal data. Thanks for watching, and I hope you enjoyed this video.